We have no other concerns with proceeding and are recommending another attempt.
LC concurs. LD?
LD concurs.
After overcoming pre-launch challenges,
Anomaly Chief.
Go.
Range Coordinator.
Go.
Launch Director.
You have permission to launch.
for just the second time,
Status check.
Go Vulcan.
Go Centaur.
Go Cert 2.
United Launch Alliance sent its Vulcan rocket on its way to space from Cape Canaveral Space Force Station.
3. We have engine ignition. 1. And liftoff.
But as the rocket roared off the pad at sunrise, one of Northrop Grumman's GEM 63XL solid rocket boosters could be seen performing oddly. There's a visual pop, and the plume on the right SRB becomes much more exaggerated as the rocket starts leaning to the right. BE-4 engines, manufactured by Blue Origin, appear to compensate for the irregularity. The rocket was able to continue through the burn of the SRBs and then jettison them a little more than 2 minutes into the flight. Winding back and slowing down the video, as the rocket was about to pass behind some clouds, from the perspective of the Kennedy Space Center press site, you can see there's a puncture near the nozzle on the SRB. With the cloud acting as a natural camera filter, the issue remains quite visible as the rocket continued to climb. Several seconds later, the pop happens, and what appears to be the SRB nozzle falls away to the right of the plume. This camera angle shows the event from the vantage point of Cape Canaveral Space Force Station. During his remarks after the launch, ULA President and CEO Tory Bruno briefly acknowledged the anomaly.
The trajectory was nominal throughout. We came to our first insertion on the orbit that we intended, so all of that is good. We did, however, have an observation on SRB number 1, and so we will be off looking into that after the mission is complete. Other than that, the flight was nominal.
In subsequent posts on social media, Bruno refuted claims that there was a so-called burn-through on the SRB casing that would have endangered the propellant. In one post on X, he says, quote, "Nozzle anomaly, case and grain fine, reduced asymmetric thrust, compensated for by booster." That compensation appeared to translate to multiple mission events adjusting their timing when comparing the launch to the timeline of events published prior to liftoff. For instance, the burn of the 2 BE-4 engines on the Vulcan booster went longer by about 5 seconds. Then, during the first burn of the RL-10 engines on the upper stage,
and we have MECO, main engine cutoff 1.
That burn lasted about 20 seconds longer than advertised. In a statement issued Friday after the launch, the Federal Aviation Administration indicated that an investigation into the issue was not warranted. No public injuries or public property damage have been reported, the agency wrote. The FAA is assessing the operation and will issue an updated statement if the agency determines an investigation is warranted. In a subsequent statement given to the publication Space Policy Online, the FAA said, "The FAA assessed the operation and determined no investigation is warranted at this time." Despite the SRB issue, ULA was able to conduct the rest of the mission with the Centaur upper stage and the inert payload. In another post, Bruno said, quote, "The orbital insertion was perfect."
And bearing jettison has been indicated.
On board the Centaur 5 upper stage were 2 payloads. The inert payload was described by Bruno as a steel structure that matches the mass, stiffness, and other dynamics of the Peregrine lunar lander. It was originally designed as a backup payload in case the moon-bound spacecraft wasn't ready to launch on the CERT-1 mission. The other payload was a set of upper stage advanced performance and technology experiments, Bruno said. Those helped gather more data about the Centaur 5 for future long-duration missions. During a pre-launch teleconference, Bruno said they're looking to get quite a bit of performance out of the Centaur in the future.
We're going to go to days, and then we're going to go to weeks, and then we think it's possible to take this to months. And that's a game changer. You know, the average upper stage is good for about an hour. You can add a bunch of stuff to it to, get 5 or 6 hours out of it if you were trying to go GSO. Other people don't. Just because, for one thing, if you're doing all that, booster reuse is not in the cards. They have to be expended. And most of the other guys have business models that are based on going to LEO and flying the first stage home. You can't even get the first stage home if you're trying to do this. So, we're already way out past that, and as we go to days, there's a whole lot of missions that enables. So that's a big step in capability, both for the United States, but also commercially.
Originally, the CERT-2 mission was designed to give a ride to Sierra Space's Dream Chaser spaceplane to the International Space Station. However, because the vehicle wasn't ready in time, ULA had to launch a mission without a paying customer on board. Bruno says the mission cost was in the high tens of millions of dollars.
We waited as long as we could to give them every chance, and they just needed a little bit more time. In fact, we had other customers that wanted to be on CERT-2 if we weren't going to be able to fly Dream Chaser, but we waited so long that we couldn't really get those integrated in time either. That's how interested we were in the Dream Chaser mission and how much we believe in their vehicle.
The primary objective for the CERT-2 launch lies within the name. This was the second and final planned certification flight before Vulcan is approved by the U.S. Space Force to begin launching national security payloads. The rocket is booked for 25 such flights for a combination of the Space Force and the National Reconnaissance Office. The components for the first two of these missions, USSF-106 and USSF-87, are both here at the Cape. Back in July, ahead of the final national security launch using an Atlas V rocket, Colonel James Horn spoke about the certification process.
Things are progressing well. We've had a lot of good reviews. We've overcome some major obstacles, and we're excited to get going this year.
Spaceflight now reached out to the U.S. Space Force's Space Systems Command regarding the next steps. In a statement, an SSC spokesperson said, "The government worked with industry to jointly develop a certification process that outlines a three-phase approach, with 25 major categories that encompass process assessment, design and qualification hardware and software evaluation, launch site assessment, and verification and validation to meet USSF mission requirements for all mission orbits." The USSF currently expects the completion of all Vulcan certification activities in 2024. Asked how long the certification process was expected to take, Bruno said during a pre-launch teleconference that, with a by-the-books mission, certification should come in, quote, weeks, not months. Bruno also spoke about what the outcome could be with an anomaly during flight.
We would investigate it, we would fix it, corrective action, and then, we would, depending on what the anomaly is, that might be sufficient. Sometimes you can retire that with analysis or ground testing. Sometimes it's the sort of thing you'd have to fly again. If that were the case, then we'd fly again.
After certification, the USSF-106 mission will be the first up to bat for the Vulcan rocket. Time will tell when that mission is clear to launch. Reporting from Cape Canaveral Space Force Station. For Spaceflight Now, I'm Will Robinson Smith.